Hey guys, I hope everyone's doing well. Let's talk about quadratic functions. So here we have a quadratic equation, 2x plus 2, x squared plus 2x minus 8. So the first thing we're going to do is find the axis of symmetry. And we do that by using the equation or the formula negative b over 2a. And that's always our x value. So our a is 1. Our b is 2, so we're going to find the opposite of b, which is negative 2 over 2 times 1. So 2 divided by negative 2 is negative 1. So our x value is negative 1, and our equation is x equals negative 1. That's the line of symmetry. The vertex, we already have half of our coordinate, which is negative 1. And then in order to find our y value, we're going to plug in negative 1 for x. So in the original equation, negative 1 squared is positive 1 plus 2 times negative 1 is negative 2. So 1 minus 2 is negative 1, and negative 1 minus 8 is negative 9. Just plug that straight into the x values here. The x-intercepts is what x is when y equals 0. So we're going to set this thing equal to 0. We're going to ignore this part right now. We're going to exchange f of x for y, and y is equal to 0. So we're thinking of two numbers. When we multiply, we get negative 8, and when we add, we get positive 2. So those two numbers would be positive 4 and negative 2. Always double check it. Does 4 times negative 2 equal negative 8? And does 4 plus negative 2 equal positive 2? Yes. Since the equation is equal to 0, we're going to take both sets of the parentheses, set them equal to 0, then solve for x. So on both of them, if we solve for x, we would get negative 4 and positive 2. And the y values are 0 because we're looking for the x-intercepts. All right, what about the y-intercepts? The y-intercepts is what we get when x equals 0. So we're going to come up here to our original equation. We're going to make all of those x's zeros. So 0 squared is 0. 2 times 0 is 0. And 0 minus 8 is negative 8. So when x is 0, y is negative 8. All right, so let's graph it, and then we'll talk about the domain and range. So we are going to graph these 5 points right here. So our vertex is negative 1, negative 9. Our x-intercepts are negative 4, 0, and 2, 0. And then our y-intercept is 0, negative 8. So we have a parabola that opens upward. Looks like this. Now, this parabola would go on and on and on forever. So when we graph it, we're graphing a very, very, very small part of our graph. It would go on forever. We just don't want to have coordinate planes that go up into the thousands, right? That doesn't make sense. So when we think about our domain values, which are x values, there is no end to how far this parabola is going to spread from left to right, because it's going to keep going out as we go up and up and up, right? So basically the domain is, you would say it's all real numbers. And to write that in, what's it called, notation, interval notation, you would basically say that since there's no limit to x values, you would say that x ranges from negative infinity to positive infinity, okay? Now, our range talks about how tall our parabola is. Now, it doesn't have a limit on how tall it will get, how far up it will go, but it does have a maximum, right? So the maximum value, I should say minimum. I said the opposite word, you guys. Please forgive me. We have a minimum for a parabola that faces up. So the very lowest point, our place on this parabola is when y is equal to negative 9, right? So when y is equal to negative 9, that's our lowest point, but then it'll go up forever. So when x is negative 1, But then there's no limit to our, how tall our parabola is going to get. Okie dokie. All right, let's move on. So you guys do have a good lesson on Florida Virtual over this particular section. I like it. I like the videos. I like the explanations. You'll have this exact scenario where you're comparing three functions. So basically, if someone kicks a ball or throws a ball, or if a rocket goes up and then it gets a maximum height, it'll come down. So if you throw a ball, it's going to go up and it's going to create the shape of a parabola. It will eventually have a maximum height, and then it will fall down, you know, very symmetrical to how it went up. Of course, this happens very, very fast. So this is always going to be a downward facing parabola, which means our leading coefficient must be a negative number, because you would never kick a ball and it would go down below the ground and then come up. That's not how science works, right? So just remember that when you ask how high will it get off, they're always talking about the maximum value or the maximum height, which is the same thing as your vertex. So the vertex and the maximum height is the same thing. So that's what they're looking for. So make sure you read this section, figure out what the answer is on your own of this particular problem, and check your answer on Florida Virtual. All right, so here we have a scenario. It says this function models the monthly profit in dollars a shop makes for repairing windshields. X is the number of windshields repaired, and f of x, or y, is the amount of profit. Okay, so the first thing we're going to do is determine the vertex. So that's where we're going to use our negative b over 2a. So our a is -1, our b is 60. So the opposite of 60 would be -60 divided by 2 times a, and our a is -1. So -60 divided by -2 is +30. So our x value is 30. And then to find our y value, we're going to plug in -30 into the equation. So just use your calculator, make sure you use parentheses for the opposite of, and then parentheses 30 squared. And then we're going to do plus 60 times 30 minus 116, and we get 784. Now it asks, what does this mean in context of the problem? So if you will use these words right here, it's going to help you answer this question. So this is the monthly maximum. What does it say? Well, so basically what the vertex is, remember, is the maximum. So when we find the vertex, basically we're finding in 1 month what the maximum profitability would be. So on average in 1 month, if the store repairs 30 windshields, it will profit $784. And in parentheses, I'm going to write the maximum. This is the maximum profitability. Profitability. So imagine that graph. Obviously, we don't have a graph that goes up to these big numbers, but so the vertex is going to be the highest point, and then as you go away from the vertex on both sides, the profitability will decrease, actually, won't it? It'll decrease. So that's why this is the maximum profitability. This is like the sweet spot of making profit for how many, what's the maximum number of windshields we have to make or repair in order to make our maximum profit. This is it right here. So let's determine now what the y values are. The x-intercepts are by setting this equation equal to 0. So we're going to do the opposite of x squared plus 60x minus 116, and we're going to set it equal to 0. So to factor this, first thing I'm going to do is factor out that -1, which basically will change by signs. So now I'm thinking about two numbers that when I multiply them, I get negative 116, but when I add them, I get negative 60. And so that would be negative 58 and negative 2. So now, since this is set equal to 0, I'm going to set both of these equal to 0 and then solve for x. So that means my x-intercepts are 2, 0, and 58, 0. So now once again, it's asking the context of this point, or what is the value of these points? What does this mean in the context of this problem? So remember I said as you get far, as you go away from that 30 for the x value, your profit decreases. So this means that if I repair, or whoever's working, 2 or 58 windshields, we break even, or I break even. It's the break even point. Okay, so there's no profit to be made at all if I make if I repair either 2 windshields or 58 windshields. And in fact, if I repair less than 2, which is 1 or 0, or more than 58, I'm actually going to start losing money, right? I don't know if it's about labor, it's about cost, whatever, but that is the maximum profitability. And with the maximum profitability, eventually you hit 0, that I'm not making any profit anymore. And those are the two numbers that will make us break even. Okay. I hope that helps you guys, because you'll answer questions very, very similar to these. All right, let's look at the next part. This is a different question. It says to find the average rate of change from -1 to +1. So let's see what's happening from -1 to +1. So from here to here, what's happening to our parabola? It's decreasing from this point to this point. It's decreasing. But then what happens when we reach -1? Well, from here on forever to the right, it's increasing. So we're starting off by decreasing, and then we go to increasing. So the average rate of change is going to be different according to what points you choose. So this one's being very specific, and it's telling us to pick the x values of -1 to +1. So at -1, so let's write our coordinates. -1, our y value is 0. And then at +1, our y value is -4. So you guys remember how to find rate of change, y2 minus y1 over x2 minus x1? So to go from -4, so -4 minus 0 is -4. And 1 minus a -1 is 2. So the average rate of change from -1 to 1 is -2, which makes sense because this is decreasing. It is decreasing. It should be a negative number. Absolutely. So now it's asking, what is the average rate of change from +1 to +3? Well, from +1 on the x value, on the x-axis, from +1 to +3, now it's increasing. So I bet you we'll get a +2, but let's plug it in and figure out for sure. So when x is -1, y is -4, and then when x is 3, y is 0. All right, so let's do our change from 0 minus a -4. 0 minus a -4 is +4. And 3 minus 1 is 2. So our rate of change is +2, which makes sense because, like we said, that's increasing from those 2 points. All right, now you're going to read through Florida Virtual the information about transformations. So I know this section can be a little overwhelming, but there's graphs that you can manipulate. And I want you to watch as the numbers change, how your graph changes, okay? So for more information on transformations, there's a good slideshow that will be very specific. If you'll go to this link, you'll find that. And then I'm going to show you guys Desmos. Have you guys heard of Desmos? Let me share that screen with you real quick. Desmos will be your friend. I don't know why I can't. There we go. It wouldn't let me end my PowerPoint presentation. All right, so I'm going to share with you. There it is right here. So this is just desmos.com. And you guys can literally put in any equation you want to, and it graphs it for you. How cool is that? So you're going to type in, so even though if you might have some equations that have variables other than x and y, you can only use x and y in Desmos. So let's say I want to do x squared. So use your shift and then your caret button, you know, that one that looks like a top of an arrow. So x squared, and then I'm going to right click. So look, immediately I get a quadratic equation. So we'll say plus 2x. Ooh, that is not what I wanted. What did I just do? We're going to do plus 2x minus 4. Okay, so did you see every time I typed in a number, my graph jumped around? So I'm just showing you Desmos. This is going to be a great resource for you guys to use to, you know, check your answers, make sure you're doing things right. If you just get stuck and you're not sure what a graph's supposed to look like, then go to Desmos and type it in. And this thing will help you as you continue through math. I mean, this will do like it does logarithms. I mean, it has everything on here, right? You could put in a log or whatever you need to do. So this is a great, it has trigonometry notation, statistic notation, so on and so forth. So this is a very valuable resource. I hope you guys will remember and you will use that. I mean, there's several out there, but that's just a great one. So anyway, my point is, yeah, it's good to know the transformations and to be able to pick them out really quickly, but there are resources to help you figure out, okay, if I put this number as a -3 and this one as a +2, how does my graph change? And you can literally change them on there. All right, so basically this is how Florida Virtual sums it up. That's on the last screen of your lesson 9.01. And then I like the graphs that you can manipulate. This one is a little more clear. So if you have within this parentheses x plus -3, that -3 is actually telling you your parent graph is what they call it. You take the original graph, and then if you shift it to the right 3, I know you think negative means left, but not in a quadratic when it's like this. Okay, so then at the very end, if that number at the very end, the constant is +3, that means that you're going to shift this parent graph up 3 units. If it were -3, it would go down 3 from the original parent function. And then the transformation that makes your graph wider or more narrow would be the coefficient of x. So as that number gets larger, the number multiplied by x gets larger, your graph actually shrinks. It sounds like the opposite. And if that number gets smaller, your graph is going to get wider. Okay, so that's just a very basic summary of how changing those numbers are going to affect what your parabola looks like. All right, so here's one of the questions that you'll have. It says, determine which of the following statements is true concerning the values described in column 1 and column 2. So it gives you 2 different quadratics, and it asks for the x coordinate of the vertex. So we can quickly find that. We can find the x value of the vertex by using this. So for column 1, the opposite of 4 is 4, and 4 divided by 2 times 1 is 2. So the x value of the vertex of column 1 is +2. And then for column 2, we're going to do the opposite of 8, which is -8, divided by 4 times, 2 times 4, 2 times 4, which is +8, so that would be -1. So the x coordinate of the vertex of column 2 is -1. So what are our choices? The value found in column 1 is equivalent to, no. The value found in column 1 is less than. Nope, that's not right. That's not right. The value found in column 1 is greater than the value found in column 2. Yes, that's true. That is true. And the relationship between these cannot be determined. That's not true. Okay, so that one was pretty simple. What about this one? All right, it says a football is kicked toward a goal. So remember, when you kick a ball, it's gonna go up, and let me erase that picture and try one more time. So anytime you kick a ball, it is going to go up, it's going to come to a maximum height, and it's going to go down. This is the maximum, right? So it says a football is kicked toward the goal. The height of the ball, this is the maximum height. T equals the time in seconds, and H of T, or Y, represents the height of the ball. What is the axis of symmetry and what does it represent? So the axis of symmetry is going to be found by using negative b over 2a. So we have the opposite of 64 divided by 2 times negative 16, which is negative 32. So a negative divided by a negative is a positive, and 64 divided by 32 is positive 2. So if this was on an XY chart, and this was time 0, this is right when this guy kicks the ball. Well, in 1 second, this is the height of the ball. In 2 seconds, this is our maximum right here, right? If it took 2 seconds to get to the maximum height of the ball, what's going to happen 2 seconds later? It's going to get down here where it started, right? Because parabolas are symmetrical. So the height of the ball is at 2 seconds, and 2 seconds later, it's going to hit the ground. So that's basically what this says. It says it takes 2 seconds to reach the maximum height and 2 seconds to fall back to the ground. So if you draw a little picture, and actually you're like, oh yeah, I totally see that. That's easy. All right, what about this one? It says the distance traveled in meters of a coin dropped from a tall building is modeled by this, where D equals the distance traveled at time T, and T equals the time in seconds. What is the average rate of change in D of T from 3 to T equals 6? All right, so what do we do? So basically, we are going to plug in these two values for T. So the first thing we're going to do is say 4.9 times 3 squared. And then we're going to do 4.9 times 6 squared. So we're going to plug those right in our calculators. So 4.9 parentheses 3 squared is 44.1. And then the other one is 4.9 times 6 squared. And we get 176.4. So when it asks you for the average rate of change, we got to use our y2 minus y1 over x2 minus x1. So when x is 3, y is 44.1. And when x is 6, y is 176.4. So now we're going to do y2 minus y1 and x2 minus x1. So 176 minus 44.1 is 132.3 divided by 6 minus 3 is 3. So when we divide that by 3, we get 44.1. Okay, so at seconds, 3 seconds, our height is 44.1, and at 6 seconds, our height is 176.4. Got it? Or that's how fast it's fallen. Okay. So which of these goes with this scenario? It says a coin falls down with an average of 14.7 meters per second. No. Where are they getting this number? I don't even know where that number is coming from. And there it is again. Okay. So we eliminated 2 without really even reading them, didn't we? So it says a coin travels an average distance of this many meters from 3 seconds to 6 seconds. A coin falls down with an average speed of 44.1 meters per second from 3 seconds to 6 seconds. So it's got to be this one because this is an average distance of 44.1 meters from this time frame. So we got a little snapshot. It's like we're taking a picture of the coin falling. And so this is the distance it travels from second 3 to second 6. So that's how we do that one. So that one was a little tough to think through, but we could quickly eliminate 2 responses. So it's easier to pick one of 2 responses than one of 4, right? All right, what about this one? It says these 2 functions, f of x and g of x, are shown. By which direction and by how many units should f of x be shifted to obtain y of x? So this is where that graph, let me go back a couple, or it's not a graph, it's just this right here. So basically, we're looking for a shift. What does it say? All right, well, if you looked at those different rules over here on this side, on this page. So basically, they want you to take this second equation and they want you to write it in, what is it called, where you find the square? Oh, the vertex form. That's what it is, the vertex form. So by now you have done the vertex form. So basically, to do the vertex form, and we're about to get to it on the next slide, we're going to think about this as 2 separate problems, or we're not 2 separate problems, but we're dividing it up, okay? So we're going to think, okay, x squared plus 8x plus blank, and then we're going to say plus 16, and then we're going to have to subtract this same amount right here. Okay, so we're going to half 8, and we get 4, and then 4 squared is 16. And then we would subtract 16. So basically what we have here is x squared plus 4. All right, so basically when this number in here is plus 4, what happened? Let's go back and look. When we have a plus 4 in with x, what happens right here? What does it say? Well, when it was a minus 3, it went right 3 units. But now we have x plus 4 squared. So plus 4 would mean we have a shift of left 4 units. Whoops, I missed it. So we're going to go left. What did I just say? Oh my gosh, I've already forgotten. It would be the opposite of, so it'd be left 4 units. That's it right there. And we had to figure that out by using that vertex form, which is in your lessons, and we're about to talk about it on the next slide. Okay, so I know this is a lot, you guys. I know it is, but also guess what? You could put this into Desmos and see what happens from the parent. This is called the parent function. And then if you type this one in Desmos, it's going to show you that the graph shifts 4 units to the left. It's a great resource. All right, here we go. So let's talk about vertex form. So here's our original equation, and here are the steps for those of you that need, to have the directions written in front of you. So the first thing you're going to do is kind of put a separation right here. We're going to do x squared minus 8x plus, and then here is our problem that our original number that we started with. So now what do? We're going to half the middle number. So in our minds, what's half of -8? The answer is -4. The next step is we're going to square that number. Well, remember, anything squared is a positive number. After you half it, you square it and you get 16. Then you're going to add 16 to the original equation where the blank is. And in order to keep our equation equal, if we add something, we also have to subtract the same amount because we're all on the boat. We're all still on the same side of the equal sign. So this is a combination of 0, isn't it? So that's why it's still equivalent to our original. And then it says rewrite the equation. So since we got that -4, we're going to rewrite it to x minus 4 squared. And then what is 12 minus 16? -4. And that is our new equation in vertex format or vertex form. Okay, and now we're going to identify the vertex. So whatever this is, this number right here, we're going to take the opposite of this number, opposite of -4 for our x value. And we're going to take the original. We're not taking the opposite. We're taking the second number, the outside number for our y value. And that's the vertex. That's why this is called the vertex form, not format, the vertex form. Because you can very quickly, if you can get it into this form, you can very quickly pull out the vertex. It's the opposite. X plus or minus is the opposite of that number, and the y value is the other number. Exactly like you see it. Okay, we're almost done, you guys. So here we have a problem. We're going to have to use that vertex form. So let's write it down here. The first thing we're going to do is factor out. Wait, hold on. We're going to say, okay, we're going to deal with just this part first. Well, I noticed that these are both divisible by 5. So I'm going to factor out 5. And 70 divided by 5 is what? 14, I think. Yeah. All right, now, remember we added a blank. And then here's our plus 258. All right, so now we are going to half -14. So what is half of -14? That would be -7. And what's -7 squared? -7 squared is +49. So -7 squared. Now, since we added 49, we have to actually subtract it. But it's not just 49, it's 5 times 49. So you can't just subtract 49, you have to subtract 5 times 49, which is -245. So 258 minus 245 is +13. So this is the vertex form of this equation, okay? And now that we have it in vertex form, we're going to say x minus 7 squared. So that means our x value is the opposite of -7, which is +7. And then our y value is this second problem, this second number in its original form. So these are the two numbers we're looking for. So what is 7 and what is 13? Well, it says right here, x is the number of products produced. So they produced 7 products, And that must be that y. The other thing they're talking about over here is the cost. Okay, so which says that? So here we have the equation we're looking for. This one's gone and this one's gone because they did not subtract 245. So we automatically can eliminate 2 of the answers. We know it's not right. And the other one, we're looking for x is the products. So we know that 7 is the products. So it says the minimum cost to produce the product is, here's our cost right there. There's our cost. The other one says our cost is $7. That's not right. So it's got to be letter B. It's got to be letter B. Okay, I think that's the last one. Maybe I'm wrong. Oh, no, it's the last one. All right, guys. So I do know that that's a lot, but you guys are smart. You hardly ever need my help. No one ever asked me anything in this class, but I hope this has helped you at least a little bit, my rambling. Thank you for putting up with me. And guys, seriously, if you need me, let me know. All right, guys, have a great day.